Hello everyone. So welcome back. Today we'll learn what is Newton's backward interpolation formula. So in the last lecture we have already learned that what is Newton's forward interpolation formula and we did some examples also. So Newton's backward interpolation formula is again almost similar to Newton's forward interpolation formula. So that's why if you didn't watch that forward interpolation formula video, that means I'm talking about lecture 4. So kindly watch lecture 4 first. Then it will be very easy to understand Newton's backward interpolation formula. Okay, so here also same. So here also we have taken a function what y equals to f of x. Okay, and some values of x which are x naught, x1, x2, and then what xn. So these values are what equidistant. So like Newton's forward interpolation formula, here also the values are what equidistant. And if we put x naught in place of f of x, we'll get y naught. Then for x1 we'll get what y1. For x2 we'll get y2, and then similarly for xn we'll get what yn. These are entries. Okay, so you all know that the values of x are called arguments, and the values of y are entries. So h is called interval of difference. So that is also we know x1 minus x0 is h. Similarly, x2 minus x1 is h. So that means distance between two adjacent arguments is what h. Now what is Newton's backward interpolation formula? Y equals to f of x. Now see here in Newton forward interpolation formula, this time is y naught, but here it is yn. So we'll start from the last. That's why it is called backward. Okay, our last entry is yn. So that's why it is, since it is started from yn, it's known as backward interpolation formula. Then u nabla yn. So I think you still remember in forward interpolation formula, it is delta y naught. So from the beginning, but it is from the end. And the third term is u plus 1. In forward, it is u minus 1 by 2 factorial, then delta square y naught. But here it is u into u plus 1 by 2 factorial, delta square y naught. So like that, other terms will follow. Now here y is also different. In forward interpolation formula, u was x minus x naught by h, but it is x minus xn by h. Okay, so these are the little changes from Newton's forward interpolation formula. So let us prove it. So here also what we'll do, we'll take a polynomial y equals to f of x. Okay, be a polynomial of degree n. Okay, and this particular polynomial will be what continuous between x0 and xn. Okay, x0 and xn. So the polynomial will choose, it will be like this, y equals to b of degree n, and this continuous between this and is continuous between x0 and what xn. Okay, so means from x0 to xn, whatever value you will put in the function, it will never be undefined. So let us take the polynomial y equals to, so I think you remember in forward also we have taken a polynomial, then after that the proof is very easy. So here also we will take a polynomial, it's a naught plus the second term is what we choose in forward interpolation formula, x minus x naught, but here it will be x minus xn. So from the last we have put, then now two factors, since we are writing 2 a2, so we have to write two factor, one is x minus xn, the next one will be x minus the previous one which is n minus 1. Okay, so we'll keep going like this. If you want to write one more 3, so we will write 3 factor x minus xn, x minus x n minus 1, and then x minus x n minus 2. So dot plus last term will be x minus xn, then x minus x n minus 1. So what will be the last factor is x minus x1. Okay, so if you count, we have written how many factors? N factors. Since it is n, so we have written n factor. But we cannot write x minus x naught, because if we write x minus x naught, it will be a polynomial of degree what? n plus 1. And we wrote here, so polynomial of degree n. So how it is polynomial of degree n? Since there are n factor, if you multiply all the factor, the highest power will be what? X to the power n. So that's why it is called polynomial of degree n. So what about a naught a1? So where a naught a1 then an are constants to be determined. So these are constant that we have to find to be determined. Okay, this constant we have to find such that you'll see those who have already watched forward interpolation formula. Now it is exactly same. So there we have choose an f of x not equals to y naught. Here we will choose f of xn equals to what? Yn. F of xn minus 1 will be our yn minus 1. So in the same way, f of x1 will be our y. Okay, y1 and f of x not equals to what? Y0. So in this same, just it will start from the last end. Okay, other things are same. So let this particular polynomial be equation number 1. So what we do now, in forward we put x equals to x naught. So here we'll putting x equals to xn, equation 1 implies. So our left hand side will be f of xn. Okay, f of xn. So f of xn you can also write yn. Now coming to the right hand side, on right hand side you see our first term is what? A naught. Okay, first term is a naught. But in the second term, I'm talking about this term. In the second term, if we put x equal to xn, it will become 0. So similarly, all the other terms will become 0. So what we have? We have only a naught. So the value of a naught is what? Y naught. In forward interpolation formula, the value of a naught is what? Y naught. But here it is a naught equals to yn. Okay. So now we'll put x equals to x n minus 1. So left hand side will be f of x n minus 1. So the first term x n minus 1, f of x n minus 1 can also be written like this, y n minus 1. First term will remain same, second term is a1 into, now see, in this particular second term, if we put x n minus 1 in place of x, then it will be how much? It will be our x n minus 1 minus xn. Okay, so this implies yn minus 1 is equals to y naught. Just now we got y naught here. You see y naught is how much? Yn plus a1 into, now what is xn minus 1 minus xn? Okay, xn minus 1 minus xn. So I think in the statement it is clearly given that x1 minus x1 how much? H. x2 minus x1 how much? H. So in the same way, xn minus xn minus 1 is also h. Difference between two consecutive arguments is what? Always h. But it is reverse, no? It is not xn minus xn minus 1. Here it is xn minus 1 minus xn. So we have to put minus h. Okay, minus h. Now let us calculate it. So from this part, our a1 will be yn minus yn minus 1 divided by how much? H. Okay, a1 is yn minus 1 divided by, I think you remember this is nothing but nabla yn by h, backward difference operator. Okay, you already did all this thing in lecture 1. So if you so always what you have to do, you have to watch serially from lecture 1 then lecture 2. So this will be your lecture 5. So come serially so that you have a better understanding and a better grasp of the subject. Okay, now let us find a2. So for a2, you have to put x equals to what? xn minus 2. So equation 1 will be, left side is f of xn minus 2, or we can write yn minus 2. Right side, first term is a naught, then second term will be a1 into, now it is xn minus 2 minus xn, then one more term will come plus a2 into xn minus 2 minus xn, then xn minus 1 minus what? Xn. Okay, xn minus will be, so last term is not like this. So our last term will be xn minus 2 minus xn minus 1. Okay, so this implies yn minus 2. First term is y naught. Sorry, first term is a naught. In place of a naught, we can put yn plus a1. Okay, a1. So just now we got a1. This is nothing but nebula yn by h, and then how much it is? Xn minus 2 minus xn. So xn minus, this is not adjacent, right? Xn minus 2, there is what? 2 gap, because if this term is xn minus 2, after that xn minus 1, then comes xn. So the gap is double. So how much we'll write here? We'll write minus twice h. Okay. If it is adjacent, then minus h. But since there is one more term in between xn minus 2 and xn, so it's how much? Minus twice h. And what about the last term? a2 into minus twice h. And then again these are consecutive, so minus h. So now we have to simplify it. So this implies yn minus 2 is equal to yn. Okay, now here h is cancelled out. Okay, h is cancelled. So this is your minus 2 into what is nebula yn? Nebula yn is yn minus yn minus 1. And the last term is plus 2h square a2. Okay, now we have to simplify it. So a2 will be how much? Our a2 will be yn. Yes, it is yn minus 2yn minus 1. 1 yn is cancelled out, so the yn minus 2yn minus 1, then plus yn minus 2 divided by how much? 2 and then h square. So it's exactly same as what? Newton's forward. So there we wrote delta square y naught. So it will be nebula square yn divided by 2 can be written as 2 factorial h square. Okay. Similarly, what will be our a3? A3 will be our nebula qyn divided by 3 factorial, then what? h cube. 3 factorial h cube. So in the same way, our an will be nebula to the power n factorial h to the power what? N. Now what we have to do with all these values? All these values we have to put in equation number 1. Okay. So let us put all the values in equation number 1. So which is our equation number 1? So this is our equation number 1. So here we have to put one by one. Equation 1 implies. So our left side will be y or f of x. The first term is a naught. So a naught is our yn. Then second term is how much? Our second term will be a1. A1 is how much? Nebula yn by h. And then with this what we have? X minus xn. Then third one is a2. Our a2 is nebula square yn by 2 factorial h square. Then with this we have 2 factor x minus xn and then x minus x n minus 1. Okay, n minus 1. In the same way, we'll put all the other terms. So let us write the last term, nebula to the power n n factorial h to the power n, x minus xn, then x minus xn minus 1. So what is the last term? X minus x1. Okay, so you can see this is not the Newton's forward interpolation formula in a given form. In the statement, you see, it's like this. U, okay, U should be there. So U into U plus 1. So we'll now convert this in terms of U. What is U? U is our x minus xn divided by h. So let us cross multiply it. So after cross multiplying, you will get x equals to xn plus uh. Okay, xn plus uh. So then what will be our x minus xn? X minus xn is how much? Uh. Okay, from this x minus xn is uh. And what is x minus xn minus 1? So in place of x, you can put xn plus uh. And what is xn minus 1? It is xn is what? Xn is x naught plus nh. So what is xn minus 1? So this will be your x naught plus n minus 1 into h. So what will write? You can write xn minus 1. You can write like this also xn. This is first term is xn, then uh, and then if it is xn minus 1. Okay, let us write like this. Not don't take it in terms of x naught because all the terms are in terms of what? Xn. Okay, so you can write like this also. So for the time being, let us keep xn minus n as it is, xn minus 1 as it is. So see, xn minus xn minus 1, you can write in one bracket uh. So what is xn minus xn minus 1? This is nothing but difference between two consecutive arguments, which is h, uh. So if you take h common, okay, how much you will get? U plus 1. Okay, so you see the pattern is also like this, u plus 1. Okay, so let us write one more, x minus x n minus 1. So if you calculate, you will get h into u plus 2. So in the same way, what is our x minus x1? X minus x1 will be in place of x, you can write xn plus uh minus how much? X1. Okay, minus it is x1. So it is xn minus x1 plus uh. So see, now it is the difference between last argument and second argument. So the difference is n minus 1. So n minus 1 into h plus how much? Uh. So if you take h common, so if you take h common, it will be u plus what? N minus 1. Okay, u plus n. Now all these values we now have to put in equation number 2. Okay, so let it be equation number 2, the last one. So this one, this equation, let us take this equation number what? 2. We'll put all the values in equation number 2. Equation 2 implies, so it's either y or you can write f of x. First term is yn. Then how much? Nabla yn into x minus xn. So our x minus xn is u. Then x minus xn. So how much it is? U. Then h into u plus 1 by how much? Nabla square yn by 2 factorial h square. So here see h square. So first term is, our first term is uh. Okay, so h and h square will cancel out. So similarly, third term is uh, then h into u plus 1, h into u plus 2, then our nabla cube yn divided by 3 factorial what? H cube. So here 3 h, you see 1, 2, 3, h cube will be cancel out. So the last term is h into u plus 1. So like this, it's h into u plus n minus 1 nabla to the power n yn by n factorial into h to the power n. So if you observe, there are n h, 1, 2 other terms, so we are not writing. So all the h will be cancelled out with h to the power. The next time is our exact form which we want. So yn u nabla yn plus u plus 1 by 2 factorial nabla square yn. Okay, so the last term will be like this, u plus 1, then u plus n minus 1 by n factorial nabla to the power n 1. Okay, so this is the form which we have written in the statement. So this is our Newton's forward interpolation formula. So this formula also you can say that you can also say that Newton's Gregory what backward interpolation formula. Okay, backward interpolation formula. And since we are writing yn, no yn, so that's why it is called backward. Okay, and when we can use Newton's forward interpolation formula, we say that the the value of x at which we want to find the value of y. If it is near the beginning argument, then we have to use what forward. Otherwise, if it is at the end, then we will use backward interpolation form. So let us take one example, then it will be very much clear. So the population of a country are given in order. So what is 1981? So different years are given. So what is the age here? You see, the first time is 1891, second is 1901, then 1911. So the difference is that what age? At which year we have to find 1925. So see, the starting number is 1891 and the last number is what 1931. So which one is the middle one? The middle one is our 1911. So if this is the middle number, now you observe at which point we have to find it's 1925. Since it is 1925 will come after the middle term. It's not at the beginning. Okay, it will be after 1911. Since it will come later, or it is in the second half of the middle one. This is the middle term. So that's why you have to use one backward. But if it is suppose 1907, so then it will be in the first half. Okay, first half. So then what we'll use? We have to use Newton's forward interpolation formula. So just check the first number and the last number and the middle number. So if the number at what point we have to find the value of x, if it comes after the middle number, then backward, and if it comes before middle term, then we have to use what forward interpolation formula. Okay, some different populations are also given. So how many arguments are here? 1, 2, 3, 4, and then 5. So if there are 5 arguments, so in the difference table, we have to make up to 4th order. And what is u? U is x minus xn divided by h. Okay. So x means what? X means at which point we have to find 1925. Then xn, this is our xn, last number. This is our xn. So it's what? 1931 divided by h. H is how much? 10. So this is important. In forward, we wrote x minus x naught. So if we write x naught means the starting number, which is 1891. Okay, so that we have to remember. So this is the table that we have to make. So population wise, okay, population wise, we have to make the table, and then the other terms will follow. So see, first is year. How many years are given? Here, 5 different years are given. So which is our argument? Okay, which is our argument? So 1981, then 1905. So here 5 different arguments are given, and similarly the corresponding entries are also given. Now we'll first make the difference table. Now if you observe that I wrote delta here, not nebula. Okay, so maybe you're thinking that if we use backward interpolation formula, we have to write nebula. Yeah, nebula also you can write. Then we have to subtract it in this way. It will be difficult. So let us uh, do all the sums in a similar pattern, but at last we'll have a twist. So how to put those values that I'll explain. So just like forward is 66 minus 46, how much you will get? 20. Then 18 minus this, how much you will get? You'll get 15. Then 93 minus 81, you'll get how much? 12. And then what? How much it is? 8. So in the same way, you find delta square. So delta square will be our 15 minus 5 is 15 minus 20 is minus 5. 12 minus 15 minus 3. 8 minus 12, you'll get minus 4. Then delta cube. So in delta cube, it's minus 3, minus plus. So it's 2, then minus 1, and last one is how much? Minus 3. Now the main trick will come here. In forward, see, in forward, this is our y naught. This is how much? Delta y naught. This is our delta square y naught. Then delta q y naught. And this one is what? Delta to the power 4 y naught. But here, when you use backward interpolation formula, we have to write yn. Yn means which one is yn? Last one. Okay. So here which is yn. So we have to put the values from the bottom of the table. See, this is our yn. Now this term is what? Nebula yn. So is it clear? So we are making the forward difference table, but there also you'll find all the same values. This is our how much? This is our delta square yn. Then this term is our delta q yn. And then what? This is nothing but delta to the power 4 y. So we'll put from the bottom. Okay. So the first term is this is our x0, x1, x2, x3, and what? x4. These are the different arguments. So simply what to do? First we'll find u. So I have already shown how to find u. So our u is x minus xn by how much? H. So x means at which point we have to find, which is 1925. And then our xn is the last value of the argument, which is 1931. H is how much? 10. So if you calculate it, you will get minus 0.6. Okay. Now let us by Newton's backward interpolation. Okay, interpolation formula. At what point you have to find? 1925. Okay, so this is our x here. So the formula is what? Yn. First term is yn. Then u nebula yn plus u plus 1 by 2 factorial nebula square yn. Without writing the formula also, since we know all the values, now directly we can write no harm. U plus 1, then u plus 2, how much it is? 3 factorial. Then you'll get nebula qyn. So one more time you have to write u plus 1, u plus 2, then u plus 3 by 4 factorial, then nebula to the power 4 y. Okay. So all the values we know. See, the table, from the table you see what is yn. Yn is, our yn is 101. Nebula yn is 8. Nebula square yn is minus 4. Nebula qyn is minus 1. And one nebula to the power 4 yn is minus 3. Okay. And u also known to us, u is how much? Minus 0.6. So put all these values. Okay. So after putting all these values, our answer will be like this. 8308. Okay. It is in terms of thousands. 96,000. And then these hundreds. Okay. So this is the answer. So kindly you do practice some other problems also. The methods are very easy. Okay. Or you can choose one problem also. Suppose you are taking this particular problem. Okay, this particular problem. The same problem you can find, suppose 1907. So in the same table, okay, from the same table you can find some forward. You can use forward interpolation formula, also a backward interpolation formula. Okay, so I hope it's very much clear to all of you. So if you understand, so kindly share with your friends also. Thank you.